Okay. We are going to find the new impedances in per unit for this system. So for generator number one, as you can see, this is the value. So what is the formula for converting the impedance to new? So Z per unit in a new is equal Z per unit old times S space new over S space old times, okay, I think I can move it a bit. Yes. So it's V base. Don't forget, this is old at the top side, at the, old, and V base new. That's all from this formula. So here for generator one, since you can see the voltage is okay, only the S. So the Z is in the X form is 20%. So it's 20 over 100, which is 0.2 times S space new, which we choose it as a 50 over 25. So easily you can see it's two times. So 0.4, is it one? No, yeah. So 0.4 is the final answer. Oops, is the final answer 0.4. For generator 2, exactly the same. For generator 3 is the what we call it, the base system. For the transformer number 1, 50 is there. On behalf of 25, we have 30, correct? Let me redo it. So this is for generator number 1 and 2. For transformer number 1, the value is 0.22 times 50 over 30. Then this is 30. And transformer number 2, this value transformer number 2, it's because the voltages, as you can see, the voltages are okay. So I check it before. Sorry, here is, I can check it. I change it to this part, 0.2. This is 50 over 30 again. So this is the value for transformer. For the load A and load B, again, only we have to not only change the P, we have to also convert this one, whatever they are in range. So this one, the voltage one, uh, 6.6 volt for load A, which is here, 6.6 as a voltage over the base voltage become 1 per unit. Then the P for the load A, the P is equal 20, correct? 20 mega over 50 mega, which is the value 2 over 5 is 0.4 per unit. For the B also, so this is the P base. The V base, this is the, no, sorry, the P per unit, per unit. The V in per unit also is 1 per unit. Again, for load B, the P is 15 over 50. 50 over 50, okay. Then check it, I don't know. And the V also in the same way, 11. 11 is here, so it's 1 per unit. So you can see whatever the voltage it is, it's very easy. Each part is 1 per unit. So no need to thinking what is the real voltage. We always talking about this. Synchronous motor, in this way, synchronous motor is here. So the voltage is 11. The voltage is 11. Only the S is different. So for motor synchronous, this one, the value is 25%. Oh, sorry, 25, 0.25 times 50 over 25, yes, correct, which is 0.5 per unit. And finally, for transmission line, the value given in O. So for transmission line, first we have to calculate the Z per unit. Z base. Z base is coming in the way. What is the voltage? What is the voltage at the transmission side, which is 33? So V over 2 divided by S. V over 2 is 33. Power of 2 divided by 50 mega. You can calculate this is the Z base. then this value must be divided, this value 20, this 20, which is coming from here, this 20, you can see, must divide by this value. So let's find out 33, where is my calculator? Is 33 power of 2 divided by 50 to 21. Let me change the color. How can I change the color here? I think maybe here. I don't know. Okay, no worries. It's 21. Sorry, 21.78. Let me maximize this one. Then change the color to this color. So it's color. Make it smaller. Windows Z. Uh, okay. Right now, I change the position of this one. So this is ohm. And finally, the Z of transmission line in per unit, transmission line in per unit is equal 20 over 21, 21.78. So the value coming out, this one, sorry, uh, answer times 20, it's 0.918 something. Okay. We can check by here 0.918. Is it given or not? Yes, it's here. You can see the S, this one is given 15 over 50 given. This one per unit. You can see the power factor no need to be changed. Correct. This one 50. I calculate this one for the transformer number 2 and transformer number 1. Okay, I already cover all the per unit section for this one. By the next video, I try to explain the fault in the power system and start to do the three-phase fault analysis. So in this unit, we only focus on the three-phase fault. We ignoring the single phase and double phase because the the fault current for these two, means single phase and double phase, are not significant compared with a three phase. All the power system and the breakers are designed in the way to operate under three-phase fault because the single-phase fault is not a major. Whatever, 70% of power system, 70% probability of the fault in power system coming as a single-phase line. And three-phase fault are only 5%, if I'm not mistaken. Only 5%. 75, the others belong to this one. Okay, the other belong to this one. Thank you very much.